Hey, Mr. Riley here with a video lesson on adding and subtracting unlike fractions. So we last talked about adding and subtracting fractions with common denominators, also known as like fractions. It's really great when they work out that way, but a lot of times the denominators in fractions are not the same, and so you have to get a common denominator. So that's what we're going to be looking at here. Adding unlike fractions. So when you add fractions, you must add or subtract fractions. You must have a common denominator. The pieces of the fractions must be the same sizes. You can't add pieces that are different sizes. So the denominator of the fraction tells you what the size of the pieces are, how many pieces there are in a whole. So they have to be the same. And there are two ways to do that. The first way is to get the least common denominator, okay, which is the smallest multiple of the two denominators, or all the denominators that you have in your problem, okay? The other option, which you might have looked at in a previous video, is the easiest common denominator, and that's always gotten by just multiplying the denominators together. A lot of times they're the same, but sometimes multiplying them together gives you a much bigger number, whereas there's a lower number that is a multiple of both, okay? So in this case, thirds and seconds, the common denominator there is 6, because 3 and 2 both divide into 6. What do you do to 3 to get 6? You multiply by 2, so that's what you do to the top and the bottom of this fraction, which they show here, and then the same thing with the second fraction. You do not have to show this step when you are doing these problems. Use getting a common denominator and rewriting equivalent fractions with a common denominator you can do in your head, okay? So you don't have to show that multiplication step. All right, so example 1 here, 3/5 plus 1/3. Answer this and write in simplest form. So first, the denominators are not the same. The common denominator is 15. So 3/5 is equivalent to 9/15, and 1/3 is equivalent to 5/15. You do that step. You don't have to write it down, okay? Now, if you're having trouble with fractions, then you might have to write it down for a little while till you get proficient, all right? But again, in an advanced class, you should not have to be writing this stuff down to get your two fractions with common denominators, okay? Then once the denominators are the same, now it's the same as the last lesson. You add the numerators and you keep the denominator the same because that's the size of the pieces. And so you end up with 14/15 here as your answer. And as always in the book here, it talks about maybe doing estimating, right? Like round these to the nearest integer and estimate what your answer is supposed to be so that you can make sure your answer is reasonable. There's a lot of multiplication going on and things like that. You can make mistakes with common denominators. And so simple arithmetic mistakes like that might get highlighted when your answer doesn't make sense from the estimate that you do in the beginning. All right, so here's how I like this work to look. 1/6 plus 3/4, 6 and 4. The lowest common denominator is 12 for those, okay? So that would be 1/6 is 2/12, multiply both by 2, and 3/4 is 9/12, okay? So then the denominators are the same. You add the numerators and you get 11/12. If you did the easiest common denominator for this one, you would have 24ths. You'd end up with 4/24 plus 18/24 is 22/24, and then you have to simplify at the end. So it's always easier if you do the least common denominator, you have less simplifying to do at the end. Okay? All right, so go ahead and do 1B here. The common denominator for this problem is 14, so only the 2/7 has to get changed to 4/7. And so 4/7 plus 4/14 plus 3/14 is 7/14, or 1/2. That one was easy enough to do in my head. I didn't even write down an intermediate step. Same thing with this one. 2/5 and 3/10. Well, you only have to convert this one, 2/5 to 4/10, and so then your answer is 7/10. And the last one here, 3/8 plus 5/24, and again, 8 and 24, the lowest common denominator there is 24, so you only have to convert the 8s. 3/8 is the same as 9/24. 9/24 plus 5/24, 14/24, which simplifies to 7/12. All right, let's see if we can do a little better on the next one, which they get harder. Okay, find sums. Now we're talking about positive and negative fractions. So the difference here, when you're adding the numerators, you add them like you add integers. So you have to use those rules, right? Always put the minus sign on the top. Okay, put the minus sign in the numerator. And common denominator. So for sixths and eighths, the common denominator is 24. Again, you could use 48, the easiest common denominator over here. Okay, you could do that, but the numbers are easier. Okay, and the simplification is easier if you use the lowest multiple of 6 and 8, which is 24. So 6 goes into 24 4 times, so that's negative 20 24ths, and 1/8, the equivalent of that is 3 24ths. Now you're going to add these numerators together using the rules of positive and negative numbers. So negative 20 plus 3 is negative 17. So negative 17 over 24 is your answer. You can leave it like this with the minus sign on the top, or you can write it more stylishly like this with the minus sign in the front. We talked about that in the last class. Okay. All right. Now we have mixed numbers and addition. Okay. Now, subtracting mixed numbers requires regrouping. Well, it doesn't require regrouping. You could always go to an improper fraction. But when you're going to add the quantities together, like in this problem, okay, because these are both negative numbers, which means I'm going to add their absolute values, well, then you can just add mixed numbers. It's much easier than converting this to a crazy improper fraction and getting these big numbers here. Okay, 115, I don't need to do that. I can't do that in my head very easily a lot of times. All right, so my preference here is since you're adding these values, because negative plus negative, you're going to add the values, just convert the fraction part to an equivalent fraction with a common denominator. So the common denominator for 10 and 4 is 20. 3/10 is the same as 6/20, and I put the minus sign in the front there. Okay. And then 3/4 is 15/20. So this becomes negative 5 and 15/20. The negative 5 is going to be there in my answer. Okay, it's down here. And then add the fraction parts. Negative 6 plus 15. Negative 6 plus negative 15, because they're both negative. That's why I said we're adding these, is negative 21. Okay. Once you're in the mixed number, everything is negative in this mixed number. The 5 is negative, and so is the 15/20. Okay, so it's adding negative 6 and negative 15, which gives me negative 21. 21/20, that's an improper fraction. So that's the same as 1 and 1/20. So I have to change the whole number part here to add that 1 on there. And my answer is negative 6 and 1/20. You see they do it here with improper fractions. Yeah, that's a safer way to do it, especially if you have a calculator. You can do the bigger numbers, but you can't do a lot of times. You can't do these in your head very easily. And with using the mixed numbers, it's typically easier to do it all in your head, which you should be able to do. Okay, so my preference is get a common denominator and regroup if you have to subtract, not using improper fractions. For accelerated students, that is the preference. Okay, and you'll see a subtraction problem here, okay, that this 2b, that's going to be one, and same thing with 2c. These are both going to require subtracting, and so that's where we need to look at regrouping. All right, so we'll go through those separate. All right, so got it, problems here of adding some mixed numbers. So fourths and 14ths, yikes, that's a rough one. The common denominator here is 28. Okay, 4 goes into 28 and 14 goes into 28. So we rewrite these with the common denominator. 3 and 3/4 is the same as 3 and 21/28, because you had to multiply 4 by 7 to get 28. And then this is 10/28. Okay. So again, I'm not going to convert this to a mixed number either here or down here. I mean, convert to an improper fraction rather. Okay. I'm going to add the fraction parts. And so I get 21 plus 10, that's 31/28. So it's 3 and 31/28, which is, of course, an improper fraction. That's 1. 28 goes into 31 one time with 3 left over. So my final answer is 4 3/28. 4 3/28. Okay, that's addition. Now we get to subtraction, and subtraction of mixed numbers is the most difficult fraction operation to do. Okay, because not only do you have to have a common denominator, but then sometimes in subtraction you have to do regrouping. All right, so let's take a look at this problem. Negative 6 8/9 plus 7 5/12. So first off, your estimation of this problem is like negative 7 plus 7.5, right? It's about negative 7 plus 7. My answer should come out to about a half, positive 1/2. Okay, that's my estimate. Always good to do. The common denominator for 9 and 12 is 36. 9 times 4 and 12 times 3. Okay. So negative 6 8/9 is the same as negative 6 and how many 36ths? 4 times this, so 32. Okay, plus 5/12 in 36ths. Multiply the top and the bottom by 3, and that's 15 36ths. Okay, so now I have a common denominator. Now what do I have to do? Well, this is an addition of a positive and a negative number, which means I'm actually subtracting the values, the larger number minus the smaller number. Okay, so it's 7 and 15 36 minus 6 and 32 36. And when you do this subtraction of mixed numbers, you look at the fraction part and you realize that I can't do 15 36 minus 32 36. Can't do that. So I'm going to regroup this 7 and 15 36. I'm going to change this to 6 and add 36 to this. 6 and 51 36. Right? These two things, these two values are equivalent. This one, 7 and 15 36, and 6 and 51 36. They are equal. This is the regrouping. Okay? And I had to do that because I couldn't do 15 minus 32, which is what I would have had to do. Okay, so now I can do this 6 and 51 36 minus 6 and 32 36. 6 minus 6 is 0, so there's no whole number part. And 51 minus 32 is 19. So my answer is 19 36ths. That cannot be simplified because 19 is prime. And it is just almost exactly a half, right? It would be 18 36 would be 1/2. So it matches my estimated answer for this problem, 19 36ths. All right, 2C, try this one on your own. We'll do a question on the final answer of this one. Common denominator for 5 and 6 is 30, 5 times 6, so that's the only thing you can do. Change these to equivalent fractions. That's 18 30ths and 25 30ths, right? Multiplying both of these by 6 to get 30 in the denominator, multiplying both of these by 5 to get 30 in the denominator. Okay, now I look and it is it's an addition of numbers with different signs, which means I'm going to subtract the absolute values. Do I need to regroup in this problem? No, because 4 and 25 30ths minus 3 and 18 30ths, I can subtract the whole number parts and I can subtract the fraction parts. Okay, so it's 4 and 25 30ths minus 3 and 18 30ths is 1, and 25 minus 18 is 7. So it's 1 and 7 30ths. Is it positive or negative? That's when I look up here and see what the sign is of the larger of these two numbers, the larger value. Okay, so the larger absolute value, oh boy. The larger absolute value is the 4 and 25 30ths. So my answer is negative 1 and 7 30ths. Negative 1 and 7 30ths. Forgot to estimate this one. Let's see, that's 4 minus 5, so negative 1-ish. There you go. Okay. Well, I'm sure we have some subtraction problems now, but subtraction problems are addition problems because we don't do subtraction. They're the same as adding positive and negative numbers. We just did subtractions, okay? So you change subtraction problems to same change, then you use your rules for positive and negative numbers. Okay, so this first one, 3/8 minus 3/4. Sometimes you can do these in your head, right? That 3 minus 6, that's -3. 3 plus -6. Okay, so that one's pretty simple. This one, a little more complicated. Okay, so 9 3/5 minus 7 2/3. This is not positive and negative numbers. Okay, but this is a third grade subtraction problem if there wasn't any fractions in there. But 3/5 and 2/3, when you make them a common denominator of 15ths, you end up having to regroup. Okay, now the book, of course, goes through changing these to improper fractions. Okay, I don't really like this method. It takes longer. It's crazy big numbers. Okay, my preference here is to regroup. So that work is shown underneath here. This is how I would do this problem. I'm going to paint this blue. Blue, I say. Okay. So common denominators here for the fraction part is 15. So this is 9 and 9/15. Okay, because you multiply the top and the bottom by 3. And then this is 7 and 10/15. Multiply the top and the bottom by 5. Okay, so 9/15 minus 10/15. I can't do that. Don't be tempted. Some people will be tempted to make this -1/15. Okay, but you can't do that because the whole numbers and the fraction parts then are kind of going in opposite directions. You can get very confused. So I would not recommend doing that ever. Regroup this so that the fraction part on the larger number is bigger than the fraction part on the smaller number. Change 9 and 9/15 to 8 and 24/15. Add 15/15 to this and take away a whole number. That's what regrouping is. Okay, so the 9 becomes an 8, and you add 15/15 to the problem up here, gives you 24/15. Now you can subtract. 8 minus 7 is 1, and 24 minus 10 is 14. And so my answer is 1 and 14/15. 1 and 14/15. They're close to the estimate. 9.5 minus 7.5, or minus 8, about 1.5, maybe 2, close to 2. Okay. So these 3 got it problems now are the key problems to do you have it or not, because these are the hardest ones we have to do. 3A. 3/4 minus 8/9. First common denominator, 36. Next, what are the equivalent fractions? 3/4, the equivalent of that is 27/36, and 8/9, the equivalent of that is 32/36. Okay, so now this subtraction, I don't do subtractions, I change. Change this to addition, change this to its opposite. It becomes 27/36 plus -32/36. You can put all that in the numerator. Now, adding two numbers with different signs, you subtract the values and take the sign of the larger value. So 32 minus 27 is 5. So this is -5/36. And again, your minus sign could be up on the top here or more stylishly out in the front. All right, 3B. 7 1/6 minus 6 5/8. I'm going to have to regroup here. I can tell because this fraction is going to be smaller than this fraction. The common denominator is between 6 and 8, 24. You could use 48. Your numbers are bigger, and you have to simplify at the end if you use 48. So 1/6 in the equivalent fraction in 24ths is 4/24, and 5/8, the equivalent fraction of 24ths, in 24ths. 5/8 is the same as multiplying by 3, so 15 24ths. All right, so now here's my subtraction, and I see that this fraction is smaller than this fraction, so I have to regroup. 7 and 4 24ths regroups to 6 and 28 24ths. Take away a whole here and add 24 here. Now I can subtract the whole numbers. 6 minus 6 is 0, so there is no whole number. And 28 minus 15 is 13. So my answer is 13 24ths, and it was a regular subtraction here, so the answer is positive, 13 24ths. 7 minus 6.5, about a half. All right, let's look at the estimate a little more importantly on this one. I never write them down. I really should. Okay, what is the estimate for this problem? 5 1/3 minus negative 4 5/9. Okay, so in your head, you should think, okay, what is this? This is about 5 minus negative 5. Okay, 5 minus negative 5. That's the same as 5 plus 5, right? So it should be about 10. Okay, the answer for this problem should be about positive 10. Remember, minus a negative is the same as adding. So this problem is not really a subtraction. It's going to be adding these two values. The common denominator of 3 and 9 is 9. Okay, if you do 27, the easiest common denominator, by multiplying these, you get a lot bigger numbers to deal with. No fun. Okay, much better to just recognize that I can make both of these 9ths. And that 1/3, the equivalent of 1/3 is 3 9ths. Okay, so here's my rewritten problem now with common denominators. This becomes plus a positive. Okay, so it's 5 3/9 plus positive 4 5/9. Adding mixed numbers, add the whole number parts, add the fraction parts. 5 plus 4 is 9. 3/9 plus 5/9 is 8/9. Not an improper fraction. So that's my answer, 9 8/9. How does that match up with my estimate? Pretty close to 10. All right, so real world problems with mixed numbers or fractions and adding and subtracting. Okay, so this example, setting up a computer network and a 100-foot cable is cut and connects 3 computers. How much cable is left for the third computer? The first one took 19 1/8 feet. The second computer took 40 3/4 feet. How much cable do I have left over? Well, I would tell you, as I put in this note over here, that I would just estimate this anyway. 19 and 41, add those together, okay? That's about 60 feet, okay? 19 plus 41 is 60, so I have about 40 feet left. It's probably enough to know that you had 40 feet left. Do you need to know that you have 39 feet and 7/8 feet or whatever it is? I don't really care. But this is a problem about adding fractions, so we have to add the fractions and not just estimate like you probably would do in the real world. So first, you have to add these two together, okay, to see how much you have already used. So 19 1/8 plus 40 3/4, common denominator is 8ths. So you get 19 1/8 plus 40 6/8. That's 59 and 7/8. Okay, that's how much you have used. So that means what you have left is 100 minus 59 7/8. Okay, well, I can't do 100 minus, there's no fraction part here. So I change this by regrouping to 99 8/8. Right, I take away one whole and I make that one whole in fractions, which is 8/8. So now I can do the subtraction. 99 minus 59 is 40. 8/8 minus 7/8 is 1/8. So my answer is 40 1/8 feet. 40 1/8 feet of cable. 40 1/8 feet of cable. make sure to include words in your answer. And of course, we said the estimate was about 40 feet. Well, okay, I have about 40 and 1/8 feet. Not sure there's really a need to worry about the difference between 40 and 1/8. But like I said, this is practice in adding and subtracting fractions. All right, so I think this is our last problem here. A frog jumping contest. The winning frog jumped 21 1/3 feet. The second place frog only jumped 20 1/2. So how much farther did the first place frog jump? So how much farther means what is the difference? What is the difference in the distances? Okay, so what is the difference in the distances means I'm going to subtract them. So it's 21 1/3, the larger one, minus 20 1/2, the shorter one. All right. I need a common denominator because these denominators are not the same. So that common denominator is going to be a 6. And this is going to become 2/6. And this is going to become 3/6. Okay. It's definitely one, 6 1/3 and halves are very common. There's the ones you should be able to really work pretty quick. Okay. So it's 21 2/6 minus 20 3/6. This fraction on the larger mixed number is smaller than the fraction on the smaller one. So I have to regroup here. 21 2/6, I rewrite as 20 8/6. Now I can subtract 20 minus 20 and 8/6 minus 3/6, which is 5/6. So my answer is 5/6 feet, which no one would say in the real world. Okay. You said, the first frog outjumped the second place frog by 5/6 feet. No, you would say this in inches. And how many inches is 5/6 feet? Each sixth of a foot is 2 inches. So this is 10 inches, right? Multiply this by 12 to get the number of inches. 12 inches per foot. So 10 inches. All right, so there's a whole bunch of guided practice problems here, which I'm not going to go over in the video. We'll maybe do these in class, right? But just to review, because we had common denominators first, use your rules for adding and subtracting positive and negative numbers, and in a situation where you have mixed numbers and you have to subtract the values, if the fraction of the bigger mixed number is smaller than the fraction of the smaller mixed number, then you have to do regrouping by taking away one whole and adding that number, okay, of pieces to the fraction part, regrouping. And that's it. We'll need to do some practice on these.